I think you will agree that pricing is the perfect point at which to culminate our discussion regarding cost. We've been looking at the different methods for costing: job costing, process costing, activity-based costing, standard costing, and now we turn our attention to setting the selling price for the product that we have manufactured. And so in Chapter 8, this solution walkthrough, Problem 8.1b, is meant to illustrate one of several strategies that may be employed, or techniques that may be employed for setting your selling price, or the selling price for your product. In this example from Chapter 8, Harrington Corporation needs to set a target selling price for its newly designed product R2D2, and they provided the following data. They have direct materials, $8 per unit, direct labor, $14 per unit, variable manufacturing overhead, $7 per unit, and you may recall that these numbers would have been derived from the work in process account. We also have fixed manufacturing overhead, $2 million for the year, variable selling and administrative expenses, $6 per unit, and then there's fixed selling and administrative expenses of $1.2 million. Now these two items, the selling and administrative expenses, they are what we call period cost, in that they are related to the administration or the selling of a product and not to the directly to the manufacturing. But if you're trying to determine the full cost for your product, you would need to factor in all of your relevant cost. It says these costs are based on a budgeted volume of 100,000 units produced and sold each year. The company uses cost plus pricing to set its target selling price. So they first determine the cost, add on the markup, and that then represents their selling price. In this case, the markup is supposed to be equal to 30% of the on top of the cost. So whatever the cost is, they add on 30%, and that would represent their target selling price. We're being asked to compute several things. The first one is to compute the total variable cost per unit, the total fixed cost per unit, and total cost per unit for the product. So let's start with A. So we're calculating the total variable cost per unit, so obviously we would want to focus on variable cost. So we take our direct materials given at $8 per unit, or direct labor of 14, and our variable manufacturing overhead of 7, and our variable selling and administrative expenses of $6. Notice that we're including not just the manufacturing cost, but also the period cost of selling and administrative expenses. So total variable cost per unit is $35. Next, we calculate the fixed costs per unit. And so, of course, we take our fixed cost. So if you take the divide that by 100,000 budgeted volume, that works out to $20 per unit. And the fixed selling and administrative expenses of 1.2 million, divide that by 100,000, that works out to $12 per unit. Alternatively, we could have simply added the 2 million and 1.2, and divide by 100,000, and that would give us $32 per unit fixed cost. Our overall total costs average would be the sum of the average variable cost of $35 that we calculated initially, plus the average fixed cost of $32. And so our average total cost, which is the sum of the variable cost and the fixed cost is $67. The next thing we want to calculate is the desired return on our investment, and it's supposed to be equal to 30% of the cost. And so if we were to take the $67 that we calculated and found 30% of that, we would get $20.10. So that's the amount of profit that we're going to be adding to the cost to determine our selling price. So what we're going to do now is we're going to take the total cost of $67, add on the markup of $20.10, and that would give us $87.10. Please note that mathematically you could take the $67, which is the average total cost, and multiply it by 1.30, and that would give you the same result of $87.10. The last part of this problem is making a slight change. They are asking us to do a similar calculation for variable cost per unit, fixed cost per unit, and total cost per unit based on 80,000 units for the R2D2. And I want you to notice that really only one aspect of our calculation has to change. Variable cost per unit is constant, so the $35 that we calculated earlier will not change, right? Because this is not dependent on the number of units. The variable cost per unit is constant regardless of how many units we produce. So that's still $35. However, the fixed cost varies on a per unit basis. And so the 3,200,000, which is your total fixed cost, we will now divide not by 100,000 but by 80,000, and that would give us $40. And so the cost is going to be $75. Notice that if the ROI remains the same, 30%, this would result in a higher selling price than before. And so one of the takeaways from here would be that your production levels can impact your selling price. And so the higher the volume, the lower your average fixed cost will be, and therefore your unit cost is going to be lower. And even though you have the same markup, in this case 30%, it would give you a lower price. And that's how one of the ways that companies can compete, because a price point of $87 is more competitive than a price point of 75 times 1.30, which would be equal to, sorry about the interruption. So a price point of $87.10 would be more competitive than a price point if we were to go based on $75 cost, because then our selling price would be $97.50, which is $75 plus a 30% markup, resulting in a selling price of $97.50.